Hey Math Zapsters, welcome back to Math Zap's problem solving. Today we'll be solving and comparing linear relationships with a word problem. Now this is a bit of a longer one, but let's take it step by step and I'll read through it. You are trying to find a new gardener and your friends Alex and Lily both run gardening businesses. Alex charges a $30 base fee for his services and an additional $10 for each hour he spends gardening. Lily charges $15 for each hour she spends gardening. Write an equation in the form y equals mx plus b to represent each of the total costs of their gardening services, where x is the number of hours they spent gardening. When is it cheaper to book Alex? When is it cheaper to book Lily? Okay, so we have a lot of information here, but first, let's write an equation to represent the total cost of Alex's services. We know that the form for a linear equation is y equals mx plus b, where m is the slope, or how much we are increasing by each time, and b is the y-intercept, or our starting point. Knowing this, we know our starting point is going to be $30, and he's going to be charging $10 for each hour, or x. So we can write Alex's equation as y equals 10x plus 30, where y is the total cost, and x is the number of hours he spends gardening. On the other hand, Lily is charging $15 for each hour of gardening, which means the slope, or m, is 15, and she doesn't charge a base fee, so the y-intercept in this case would be 0. So the equation that represents Lily is y equals 15x, and we don't need to write a plus b because we have no starting point. Now let's figure out when it's cheaper to book Alex and when it's cheaper to book Lily. To do that, we must compare their total costs for different gardening hours. Here we have a table which compares the hours spent gardening for both Alex and Lily and how much it costs for each of them. So if Alex is spending 3 hours gardening, we plug x equals 3 into our equation for Alex, which is y equals 10x plus 30. So we can see here that if Alex spent 3 hours gardening, our total money would come out to be $60. Or we can see on this table that 3 hours spent gardening is $60 for Alex. Using the same strategy, we can find Lily's total cost for 3 hours, which would come out to be $45, which is also shown on this table. So, for 3 hours of gardening, we can see that it's much cheaper to book Lily. Now, let's see when it's cheaper to book Alex. We can use a trial and error technique by substituting different x values into both equations like we did on this slide, but this isn't always the easiest way. The best way to solve these types of problems is by setting each equation equal to each other, since they both equal y. To do this, we would have 10x plus 30 is equal to, instead of y, we just set it equal to Lily. Now we can solve this equation like any other. Let's start by subtracting 10x from both sides. And then we can divide both sides by 5 to get x all by itself. And we will be left with x is equal to 6. Now what this is saying is that when x, or the hours, is equal to 6, Alex and Lily's rate will both be equal. Earlier we determined that if we were only working for 3 hours, Lily would be cheaper. So we know that if we are working less than 6 hours, Lily will be cheaper. But if they're working more than 6 hours, Alex will be cheaper. We can check this using our equation, but in our case we have a table. So let's verify it. Here we have 6 hours where they're both equal to $90. We said any less than this and Lily would be cheaper. At 5 hours, Alex is $80 and Lily is $75. So Lily is cheaper. However, at 7 hours, Alex is $100 and Lily is $105. So Alex becomes cheaper. And there you have it, Math Zappers. Keep practicing and honing your equation writing and solving skills under the Linear Relationships unit on the app. Great job, and until next time, stay Zaptastic.